Did you know that every star you see in the night sky is bigger and brighter than our sun? Of the 5,000 or so stars brighter than magnitude 6, only a handful of very faint stars are approximately the same size and brightness as our sun, and the rest are all bigger and brighter. Isn't that fascinating? Have you ever looked up to the sky on a beautiful summer night? There's not a cloud in the sky when you saw that gigantic mass of stars. How did you feel? If you think that was a lot of stars, wait until you see the stunning pictures taken by the James Webb Space Telescope of the so-called star clusters. Make sure you like this video and subscribe to our channel to stay notified about the latest updates about the James Webb Space Telescope, NASA news, and other space updates. Now, let's dive in quickly. This image of the cluster Westerlund 2 and its surroundings, taken by the James Webb Space Telescope, is absolutely breathtaking. Westerlund 2 is an obscured, compact young star cluster, perhaps even a superstar cluster, in the Milky Way, with an estimated age of about 1 or 2 million years. It contains some of the brightest and most massive stars known. The cluster resides inside a stellar breeding ground known as GUM 29, located 20,000 light-years away in the constellation Carina. As its name indicates, the Westerlund 2 cluster was discovered by Bengt Westerlund in the 1960s, but its stellar content was assessed only in later years. Number 2. Extreme Star Cluster. The star-forming region, NGC 3603, seen here in the latest images taken by the James Webb Space Telescope, contains one of the most impressive massive young star clusters in the Milky Way. Bathed in gas and dust, the cluster formed in a huge rush of star formation thought to have occurred around 1 million years ago. The hot blue stars at the core are responsible for carving out a huge cavity in the gas seen to the right of the star cluster in NGC 3603's center. Number 3. NGC 1866, Multiple Generation Stars. Star clusters are common structures throughout the universe, each made up of hundreds of thousands of stars all bound together by gravity. NGC 1866 is found at the very edges of the Large Magellanic Cloud, a small galaxy located near the Milky Way. The cluster was discovered in 1826 by Scottish astronomer James Dunlop, who catalogued thousands of stars and deep sky objects during his career. However, NGC 1866 is no ordinary cluster. It is a surprisingly young globular cluster situated close enough to us that its stars can be studied individually. There is still a debate over how globular clusters form, but observations such as this have revealed that most of their stars are old and have a low metallicity. In astronomy, metals are any element other than hydrogen and helium. Since stars form heavier elements within their core as they carry out nuclear fusion throughout their lifetimes, a low metallicity indicates that a star is very old, as the material from which it formed was not enriched with many heavy elements. It's possible that the stars within globular clusters are so old that they were actually some of the very first to form after the Big Bang. In the case of NGC 1866, though, not all stars are the same. Different populations or generations of stars are thought to coexist within the cluster. Once the first generation of stars formed, the cluster may have encountered a giant gas cloud that sparked a new wave of star formation and gave rise to a second, younger generation of stars, explaining why it seems surprisingly youthful. Number 4. NGC 3201, Stars Standing Out. This image, taken by the James Webb Space Telescope, reveals a glistening and ancient globular cluster named NGC 3201. It is a gathering of hundreds of thousands of stars bound together by gravity. GC 3201 was discovered in 1826 by the Scottish astronomer James Dunlop, who described it as a pretty large, pretty bright object that becomes rather irregular towards its center. Globular clusters are found around all large galaxies, but their origin and role in galaxy formation remain tantalizingly unclear. Astronomers recently discovered a black hole lurking at the heart of NGC 3201. Its position was revealed by the strange movements of a star being quickly flung around a massive invisible counterpart. This sparkling group of stars also has some strange properties which make it unique amongst the 150 globular clusters belonging to the Milky Way. NGC 3201 has an extremely fast velocity with respect to the Sun, and its orbit is retrograde, meaning that it moves speedily in the opposite direction to the galactic center which it orbits. The unusual behavior of this cluster suggests that it may have extragalactic origins, but at some point was captured by the Milky Way's gravity. However, the chemical makeup of this intriguing cluster tells a different story. The stars within NGC 3201 are chemically very similar to those of other galactic globular clusters, implying that they formed at a similar location and time to their neighbors. Whether this mysterious cluster was adopted by our galaxy or has for some reason evolved very differently to the family of clusters it grew up with, it is certainly an unusual astronomical beauty. Number 5. The Mammoth Stars. The image shows a pair of colossal stars, WR25 and TR16 to 244, located within the open cluster Trumpler 16. This cluster is embedded within the Carina Nebula, an immense cauldron of gas and dust that lies approximately 7,500 light-years from Earth in the constellation of Carina. WR25 is the brightest, situated near the center of the image. The neighboring TR16 to 244 is the third brightest, just to the upper left of WR25. The second brightest, to the left of WR25, is a low-mass star located much closer to the Earth than the Carina Nebula. Number 6. Panoramic view of star forming. 30. Doradus is the brightest star-forming region in our galactic neighborhood and home to the most massive stars ever seen. The nebula resides 170,000 light-years away in the Large Magellanic Cloud, a small satellite galaxy of our Milky Way. No known star-forming region in our galaxy is as large or as prolific as 30 Doradus. The image comprises one of the largest mosaics ever assembled by the James Webb Space Telescope. Number 7. Stars on a diet. The star cluster. Pismis 24 lies in the core of the Large Emission Nebula, NGC 6357, that extends 1 degree on the sky in the direction of the Scorpius constellation. Part of the nebula is ionized by the youngest, bluest, heavy stars in Pismis 24. The intense ultraviolet radiation from the blazing stars heats the gas surrounding the cluster and creates a bubble in NGC 6357. The presence of these surrounding gas clouds makes probing into the region even harder. One of the top candidates for the title of Milky Way Stellar Heavyweight Champion was, until recent observations in 2023, Pismis 24-1, a bright young star that lies in the core of the small open star cluster, Pismis 24, that is the bright star in the image. Its distance is about 8,000 light-years away from Earth. Pismis 24-1 was thought to have an incredibly large mass of 200 to 300 solar masses. New research of the star has, however, resolved Pismis 24-1 into two separate stars, and in doing so has halved its mass to around 100 solar masses. Number 8. Messier 2. Star clusters are commonly featured in cosmic photo shoots and are also well loved by the James Webb Space Telescope. These large gatherings of celestial gems are striking sights, and the subject is Messier 2. Messier 2 is located in the constellation of Aquarius, about 55,000 light-years away. It is a globular cluster, a spherical group of stars all tightly bound together by gravity. With a diameter of roughly 175 light-years, a population of 150,000 stars, and an age of 13 billion years, Messier 2 is one of the largest clusters of its kind and one of the oldest associated with the Milky Way. Most of the cluster's mass is concentrated at its center, with shimmering streams of stars extending outwards into space. It is bright enough that it can even be seen with the naked eye when observing conditions are extremely good. Number 9. A symphony of colors. The Tarantula Nebula is situated 170,000 light-years away in the Large Magellanic Cloud in the southern sky, and is clearly visible to the naked eye as a large milky patch. Astronomers believe that this smallish, irregular galaxy is currently going through a violent period in its life. It is orbiting around the Milky Way and has had several close encounters with it. It is believed that the interaction with the Milky Way has caused an episode of energetic star formation, part of which is visible as the Tarantula Nebula. Just above the center of the image, there is a huge cluster of very hot stars called R136. The stars in R136 are also among the most massive stars we know. R136 is also a very young cluster, its oldest stars being just 5 million years old or so. Its smallest stars, however, are still forming, so astronomers observe R136 to try to understand the early stages of stellar evolution. Near the lower edge of the image, we find the star cluster Hodge 301. Hodge 301 is almost 10 times older than R136. Some of the stars in Hodge 301 are so old that they have already exploded as supernova. The shock wave from this explosion has compressed the gas in the tarantula into the filaments and sheets that are seen around the cluster. Number 10. A swarm of ancient stars. This stellar swarm is M80, also known as NGC 6093, one of the densest of the 147 known globular star clusters in the Milky Way galaxy. Located about 28,000 light-years from Earth, M80 contains hundreds of thousands of stars, all held together by their mutual gravitational attraction. Globular clusters are particularly useful for studying stellar evolution, since all of the stars in the cluster have the same age, about 12 billion years, but cover a range of stellar masses. Every star visible in this image is either more highly evolved than, or, in a few rare cases, more massive than our own sun. Especially obvious are the bright red giants, which are stars similar to the sun in mass that are nearing the ends of their lives. Number 11. Trapped galaxies. In the center of a rich cluster of galaxies located in the direction of the constellation of Coma Berenices lies a galaxy surrounded by a swarm of star clusters. NGC 4874 is a giant elliptical galaxy about 10 times larger than the Milky Way at the center of the Coma Galaxy cluster. With its strong gravitational pull, it is able to hold on to more than 30,000 globular clusters of stars, more than any other galaxy that we know of, and even has a few dwarf galaxies in its grasp. In this image taken by the James Webb Space Telescope, NGC 4874 is the brightest object, located to the right of the frame, and seen as a bright star-like core surrounded by a hazy halo. A few of the other galaxies of the cluster are also visible, looking like flying saucers dancing around NGC 4874. But the really remarkable feature of this image is the point-like objects around NGC 4874. Revealed on a closer look, almost all of them are clusters of stars that belong to the galaxy. Each of these globular star clusters contains many hundreds of thousands of stars. Most unusually, the image also shows a very faint blue satellite trail extending across the whole image from the upper left corner of the frame to the lower right. Such trails are very rare. Number 12. Hodge 301, the star cluster. Hodge 301 is an old cluster. Many of its stars have already exploded as supernovae. The filaments in the upper left corner have been compressed by the explosions of these stars. Elsewhere in the picture, new stars are being born. In the most active starburst region in the local universe lies a cluster of brilliant, massive stars known to astronomers as Hodge 301. Hodge 301, seen in the lower right-hand corner of this image, lives in the Tarantula Nebula in our galactic neighbor, the Large Magellanic Cloud. Number 13. The Dazzling Diamonds. This image, taken by the James Webb Space Telescope, features the star cluster Trumpler 14, one of the largest gatherings of hot, massive, and bright stars in the Milky Way. This cluster houses some of the most luminous stars in our entire galaxy. The prominent dark patch close to the center of the cluster is a so-called Bok globule. This is an isolated and relatively small dark nebula containing dense dust and gas. These objects are still subjects of intense research, as their structure and density remain somewhat a mystery. Number 14. Infant stars in neighboring galaxy. The exquisite sharpness of the James Webb Space Telescope has plucked out an underlying population of infant stars embedded in the nebula NGC 346 that are still forming from gravitationally collapsing gas clouds. They have not yet ignited their hydrogen fuel to sustain nuclear fusion. The smallest of these infant stars is only half the mass of our Sun. Isn't it pretty? Number 15. New stars are born. The red dots scattered throughout the cosmic landscape, captured in this image taken by the James Webb Space Telescope, are a rich population of forming stars that are still wrapped in their gas and dust cocoons. These stellar fetuses have not yet ignited the hydrogen in their cores to light up as stars. However, JWST's near-infrared vision allows astronomers to identify these fledglings. The brilliant blue stars seen throughout the image are mostly in the foreground. Number 16. Colorful stars in Omega Centauri. The James Webb Space Telescope snapped this panoramic view of a colorful assortment of 100,000 stars residing in the crowded core of a giant star cluster. The image reveals a small region inside the massive globular cluster Omega Centauri, which boasts nearly 10 million stars. Globular clusters, ancient swarms of stars united by gravity, are almost as old as our Milky Way galaxy. The stars in Omega Centauri are between 10 billion and 12 billion years old. The cluster lies about 16,000 light-years from Earth. The majority of the stars in the image are yellow-white, like our Sun. These are adult stars that are shining by hydrogen fusion. Towards the end of their normal lives, the stars become cooler and larger. These late-life stars are the orange dots in the image. Even later in their life cycles, the stars continue to cool down and expand in size, becoming red giants. These bright red stars swell to many times larger than our Sun's size and begin to shed their gaseous envelopes. After ejecting most of their mass and exhausting much of their hydrogen fuel, the stars appear brilliant blue. Only a thin layer of material covers their super-hot cores. These stars are desperately trying to extend their lives by fusing helium in their cores. At this stage, they emit much of their light at ultraviolet wavelengths. All of the stars in the image are cozy neighbors. The average distance between any two stars in the cluster's crowded core is only about a third of a light-year, roughly 13 times closer than our Sun's nearest stellar neighbor, Proxima Centauri. If anyone lived in this globular cluster, they would behold a star-saturated sky that is roughly 100 times brighter than Earth's sky. Thank you for watching the video till the end. Which picture fascinated you the most? Let us know in the comments below. If you loved watching this video, press the like and subscribe button to stay notified of the latest updates about the James Webb Space Telescope, NASA news, and our new video releases. See you soon in our next video.